Advanced Algebra, Chapter 6, Lesson 2, continuing to look at polynomials. And in this lesson, we want to look specifically at linear factors. What is a linear factor, and then how can we use those linear factors to help us find the zeros of a polynomial function? So let's look at the factored form of a polynomial first. Now, if you think about a number like 108, we can rewrite that as a product of its prime factors. Meaning, if I took 108 like I did here, and I did a factor tree and I found the prime factors, I could rewrite the number of 108 as a product of, or multiplying together, all of its prime factors. So 2 times 2 times 3 times 3 times 3 is the same as 108. It's the same number, 108, only written as a product of its prime factors. Now, polynomials can be written as a product of its linear factors. So let's take a look at quadratics, which we worked with before, and we'll kind of build on that. We worked on taking a quadratic before and factoring it. So we would take this would be a quadratic because it's a degree 2 and it's a trinomial, and we factored it into these two binomials. And now these binomials are called linear factors because they're factors because if I multiply them together, and any two numbers that we multiply together are called factors. So these are factors because I multiply them together to get this quadratic. And they're called linear because you'll notice that the degree of each one of these is 1, or linear. They're linear in degree. So these are called linear factors because the degree is 1 of each binomial, and because I multiply them together to get this quadratic in standard form. So much like a number, this 108, and in this case x squared plus 4x minus 12, we can rewrite 108 as a product of factors. We can rewrite this quadratic as a product of its factors. And we can do this with any degree polynomial that we have. We can write it if it has linear factors, and then we can multiply them together to get the standard form. So if we need to take some linear factors and we're asked to write it in standard form, we simply need to multiply the factors together. So let me say that one more time. If you're asked to write a polynomial in standard form and you're given the linear factors, all that it is asking you to do is to multiply these together. Now, before we move forward and look at an example of getting a polynomial from its linear factors, let's talk about how we multiply these together. And in order to do that, I want to talk about the distributive property. I want to take a few moments to talk about the distributive property because the distributive property is the mathematics behind what we're going to be doing when we're multiplying these linear factors together. And the reason I want to talk about the distributive property is because most of you have probably been familiar with or have been taught this acronym FOIL, which we use when we're multiplying two binomials together. So if we're multiplying x plus 3 times x plus 2. Now, FOIL is fine, but the problem with FOIL is it only works for a binomial times a binomial. And in this lesson, we're going to be working with not only binomials, but trinomials and sometimes four-term polynomials, and we're going to have to multiply them together. And how do we do that? And really, FOIL is just a shortcut to using the distributive property. So I want to get away from FOIL, kind of forget that you know that. Look at the distributive property. That's the math behind it, because the distributive property not only works for a binomial times a binomial, it works for any polynomial times any other polynomial if you understand the math behind it. So let's take a look at the distributive property. The distributive property says that if I need to multiply a number times a sum of two other numbers, that I can distribute this number to both of these. In other words, I take this x outside and I multiply it by this x inside, and then I take this x outside again and I multiply it by this 3 that's inside. Essentially, I distribute it to both terms inside, and by doing so I then have applied the distributive property, and I'm able to write this that's in factored form in a standard form polynomial. Again, this is factored form because there's things that can be multiplied together, and now this is standard form with the variables exponents going in descending order. Now let's take an x plus 2 times an x plus 3. And again, this looks like a FOIL, but it's actually the distributive property, because what I'm going to do is I'm going to take this x that's in this binomial, and I'm going to multiply it by both of these. So I'm going to distribute it to both of those. And then I'm going to take this positive 2, and I'm going to multiply it by both of these. I'm going to distribute it to those two. So actually, I'm doing the distributive property. So then I do x times x, x squared, and then the 3x, that's the first, that's the inner, and then outer, and then last, that's where the FOIL comes from. And now I have like terms in here, and remember in standard form, we add all the like terms together, and then we have our variables with their exponents in descending order. So this is my standard form. Okay, so that's the distributive property. And the reason we want to do that is because if we have something like this, x squared plus 5x, say, plus 6, and now I need to multiply that times x plus 2, well, how do I do this? FOIL doesn't work, but distributive property does, because I take this x squared and I multiply it by both of these. And I take this positive 5x and I distribute it to both of these. And I take this positive 6 and I distribute it to both of these, so that the math behind FOIL, the distributive property, allows me then to work with a trinomial times a binomial, or a trinomial times a trinomial, and et cetera, et cetera. So you can see the distributive property is what's valuable to us. FOIL only works for this type of problem, and if that problem is not like that, then we have a problem. So let's kind of forget about FOIL, and let's remember that the distributive property is what we're going to have to use. So now that we understand the distributive property, to put a polynomial in standard form, we simply multiply the linear factors together. So we have an example here where we have these three linear factors that we're asked to put it in standard form. This is factored form. So to multiply these together, we simply multiply any two together, and then we take that answer, multiply it by the third. Now, in this example, they chose to multiply these last two together, so distributive property gives them this, and then we simplify it by adding like terms. So now we have this trinomial times the binomial, and now we use, again, the distributive property, multiplying this x times each of these, and this 1 times each of these. We have this then. Then we simplify by adding like terms, and we have our polynomial in standard form. As a way of review, the main things we want to get out of this lesson then is understanding that these are called linear factors and why, and then how do we put a polynomial in standard form given the linear factors. We simply multiply these linear factors together, and we do that using the distributive property.